All right, so in this video, I'll be talking through page 22 of the notes packet. This is where we are introducing the concept of an inverse function. So as you can see, the kind of headline here is the inverse function represents the same relationship, but in the opposite direction. So what does that mean? Well, let's look at example 1 here for some intuition. So Mia is buying bricks to build a new patio. She knows that each brick costs 68 cents. The function below represents how much money in dollars, represented by f of x, it will cost by x bricks. So here our input is x. We're buying x bricks, and the output is the cost of the function. And the equation for this is going to be f of x is equal to 0.68x. Mia wants to build the largest patio possible within her budget. As a result, she wants to think about this function so that x represents her budget for bricks, and g of x represents the number of bricks that she can buy for that budget. Right, so here x was the input, and we were saying how much does it cost for any number of bricks. Here the budget is the input, and the output is the number of bricks. And so if we know it's 68 cents a brick, well, if we want to figure out how many bricks she can buy for 102, we want to divide 102 by 0.68. You can see that she buys 150 bricks. For 134, again, dividing by 0.68, that's going to be 197 bricks. And then for 170, she can buy 250 bricks. Okay. And what is the equation for this? Well, the equation for this is going to be y equals x over 0.68, right? We divided. See, up here, we multiplied by 0.68. Down here, we divided by 0.68. Or sorry, that should be g of x. And so the main thing I want you to take away from here is that when we are talking about inverse functions, it's always the exact same relationship, right? Whether we're talking about bricks to cost or cost to bricks, the points map one or each other. It's just a different way of looking at it, right? Instead of multiplying by this constant, we're dividing by this constant. That's the intuition behind an inverse function. You're doing the same relationship in the backwards order. And you write that f negative 1 of x, right? So the inverse of f of x, we write f negative 1 of x. If you see this f negative 1, that means it is the inverse function. Let's take a look at another intuitive example here. That's example 2. Very similar in nature. So table below shows the price for buying each size package of paper towels. So if you buy 2 paper towels, it's $2.25, 8, 7.60, 12, it's 11.20. And this function is the inverse, right? Rather than taking rolls as an input, now you take price as an input and you say how many can you buy for that. And what do you notice about these two functions, right? Look at the x values here. Look at the x values here. Look at the y values here. Look at the y values here. You might notice that the x value from this function are the exact same as the y values from this function. And the y values from this function are the x values in this function, right? That's kind of what it means when we run the thing in the opposite way. If you are familiar with what we have been talking about this unit, you should understand that we can describe that as, for the function's inverse, we're switching the domain and the range, right? Here we have the domain of 2, 8, and 12. Well, that becomes the range of our inverse. And our range of our function becomes the domain of our inverse. So let's make that a little bit more concrete down here. So here we have 2 functions, and I'm telling you that they are the inverse of each other. Right here, when you input 2, you output 3. Here, when you input 3, you get 2. Right, so it's kind of, if you think about 3 to 2, 3 to 2, 5 to 4, 5 to 4, 5 to 2, 2 to 5, 6 to 4, 4 to 6. So the domain of our function, this should say, change these to be f negative 1 of x, f negative 1 of x. There's a typo there. So the domain of f of x here is going to be 2, 4, 5, 6. The range is going to be 2, 3, 4, 5. And then here, the domain is going to be 2, 3, 4, 5. And then the range here is going to be 2, 4, 5, 6. And what do we notice? They're switched, right? For the inverse function, the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. So we switch the domain and range. That's the big intuitive idea here. We're going to build on this over the course of the next couple lessons.